Okay, so in this lesson we are going to take a closer look at this chapter for trigonometry. Okay, so the chapter for trigonometry is all about three sides measurement, and remember, a shape with three sides is a triangle. But it's very prudent while we are doing trigonometry to classify our triangles into two main groups, that we have a right angled triangle and we also have a non-right angled triangle. So a right angled triangle, a three-sided shape with one of the interior angles is with a 90-degree angle, and we know that this side is basically called the hypotenuse. And let's say if this angle theta is given, then we can also name the other sides. That the side that is next to the angle that is given is the one that we normally call the adjacent, and the side which is opposite to the angle that is given we normally call that the opposite. But remember, these names, they always vary, depends on the location of theta. If I change and say with relation to alpha, then this side is now the adjacent in relation to alpha, and this side then becomes the opposite. So you need to be very careful as these names always change. They are not fixed as what this hypotenuse is. What about on a non-right angled triangle? On a non-right angled triangle, none of the interior angles is 90 degrees. So whenever you see a triangle, you need to check, okay, am I dealing with a right angled triangle or I'm dealing with a non-right angled triangle? What do you do if you are dealing with a right angled triangle? If you are dealing with a right angled triangle, the first thing that you need to think of is the Pythagoras Theorem. The Pythagoras Theorem. Under what circumstances do you use a Pythagoras Theorem? You use a Pythagoras Theorem if you see that you are dealing with a right angled triangle. Maybe there's a side that is given and another side is also provided. Like in this case, let's say maybe this side is A and this side, let's say it's B, and this side, let's say it's C. The Pythagoras Theorem, it states that AE squared plus B squared is equivalent to C squared. So if you take this shorter side, you square it, you also square the other shorter side, the answer that you get is equivalent to the longest side squared. If you don't want to use the Pythagoras Theorem, here is the second thing that you can also think of. You can use the trig ratios. The trig ratios. What are these trig ratios? Some students, they memorize it in this way, the SOHCAHTOA. The SOHCAHTOA. So the sine of an angle, the sine of this angle theta, the sine of that angle theta is basically equivalent to the opposite side, which is A, over the hypotenuse side, which is C. And if you also go to the cosine of angle theta, the cosine of this angle theta is also equivalent to the adjacent side, which is B, over the hypotenuse side, which is C. If you also look at the tangent of angle theta, right, it's also equivalent to the opposite side over the adjacent sides. It's opposite sides, which is A, over the adjacent side, which is B. So you can also think of the SOHCAHTOA. If you've got an opposite and adjacent and hypotenuse, use sin. If you've got adjacent and hypotenuse, use cos. If you've got opposite and adjacent, use tan. So yes, I have explained this last time. This is just a hint I'm trying to provide to you. So when it comes to the right angled triangle, don't ever think of any concept. Think of the Pythagoras Theorem, like I said, as well as the trig ratios, the SOHCAHTOA. What about a non-right angled triangle? What if you want to find the missing sides and the missing angles of a non-right angled triangle? Or what you need to do, either use the sine rule, right? Under what circumstances do you normally use the sine rule? So the sine rule, at first, it states that if you take the sine of angle A, right, and divide by the length of the side which is opposite to A, the answer that you get is equivalent to take the sine of angle B, right, and divide by the length of the side which is opposite to angle B. The answer that you get again is still the same as taking the sine of angle C and divide by the side which is opposite to angle C. So under what circumstances do you normally use the sine rule? You normally use the sine rule if they give you, let's say maybe they tell you that this angle is 35 degrees and maybe this side is 10 centimeters and maybe this angle is 80 degrees and maybe this side is just x, maybe it's not given. I want you to take a closer look at this problem. In this case, you use the sine rule. So you must have an angle and a side opposite to that angle. And either they will give you the angle and asks you to find the side opposite to that angle, or they can give you this side and say it's 9 centimeters, but they won't give you this angle. So can you see this information is still available? An angle and the side which is opposite to side, and then they say find an angle, or they'll give you the angle and then they say find the side which is opposite to. In those cases, you use the sine rule. We can copy this problem and try to work it out. What about the cosine rule? Sometimes the sine rule cannot do everything that we want. So what else do we do if the sine rule can't do the job for us? We have to use what we call the cosine rule. Okay, how do we use the cosine rule? Under what circumstances do we use the cosine rule? So case number 1, we use the cosine rule if we've got two adjacent sides. Two adjacent sides and an included angle. So let's say they give you a problem of this form. Maybe they tell you that this side is 10 centimeters and this angle may be 30 degrees and this side may be 7 centimeters, and then they say find x. In this case, use the cosine rule because you have a side, right, and another side, and the angle between those two sides. So we say these two sides are adjacent, they are next to each other, and this one we call it the included angle, is the angle between the two sides. So as long as you've got a side and the angle between the two, you can find the opposite side. And secondly, you can also use the cosine rule if all three sides are given. All three sides are given. So let's take, for example, you have a triangle. Maybe this side is 7 centimeters and this side is 8 centimeters, and maybe the other side is 12 centimeters. You can find all these angles. Let's say maybe this angle is alpha and this angle is beta and this angle is gamma. In this case, you can use the cosine rule to find any of these missing angles. If you want to find angle alpha, you start your equation by saying 7 squared is equivalent to 12 squared plus 8 squared minus 2 times 12 times 8 cosine of alpha. Straight away you get your answer. In this case, if you want to find the value of x, you can also start by saying x squared is equivalent to 10 squared plus 7 squared minus 2 times 10 times 7 cosine of 30. If you do that, you can get the solution. So please don't panic when you see triangles in your question paper. Relax. Take a closer look at that diagram. Is it a right angled triangle that you are dealing with, or it's a non-right angled triangle that you are dealing with? If you are dealing with the right angled triangle, use the Pythagoras Theorem or the trigonometric ratios. But if you are playing around with a non-right angled triangle, you need to think of the sine rule as well as the cosine rule. Remember, the sine rule works much better if you've got an angle and a side which is opposite to, and then they'll give you the side and ask you to find the angle opposite to, or they give you the angle and ask you to find the side which is opposite to. Alternatively, you can use the cosine rule. If you see that maybe the sine rule is not much enough, you mainly use the cosine rule if you've got two adjacent sides and then included the angle, or if all three sides are given, you can also use the cosine rule. If you have any problem or you want me to play around with this problem that I've posed on the board, please let me know. But this is all about trigonometry. Grade 12, O level, whatever level, you need to master this idea. Awesome.